Good morning students, myself Dr. JP Sridhar, Associate Professor, Department of EEE SJIT Bangalore. In today's class, we are going to discuss about one of the important topic, that is circular convolution. Okay, so in circular convolution especially I am using a graphical method or circle method for calculating the circular convolution of the given sequences. This type of problems are compulsory in examination for 8 to 10 marks, and it is very easy also. Just closely observe what I am telling and follow the same. The problem goes like this: find the circular convolution of the given sequences using graphical method or concentric circle method for the given sequence. x1 of n is equal to 1 3 5 7 and x2 of n is equal to 2 4 6 8. Okay, these are the sequences 1 3 5 7 and x2 of n is 2 4 6 8. Before solving the problem, okay, we can discuss some of the important points in the circular convolution. To perform circular convolution, length n of both the samples should be same. So what is the length x1 of n? It is 4. What is the length x2 of n? Also 4. Okay. To perform convolution, especially circular convolution, the length of both the input sequences should be same. If the length is not same, suppose, then what we can do? We can see whichever the input is highest number of samples, we can match with the same number of samples for whichever the input having less samples as compared to the other sample one. Suppose if the length of x1 of n is 5 samples, if length of x2 of n is 3 samples, so in that time we cannot perform the convolution directly because the lengths are not same. So that time what I will do, I will make length of x2 of n as 5 by padding the zeros after the sequences. After the sequence, suppose if it is 1 1 1, I can pad the zeros after the sequences. Okay, I will make the length as 5. So this is the minimum important point. Keep it in mind before doing the convolution. Okay, observe both the length, okay, of the given input sequences should be same. And what is the length of the output sequence? Y of n. Y of n is also same as the length of the input sequences. Therefore, your output also contain 4 samples. Okay. These are the minimum points. Okay, you should keep it in mind before solving the circular convolution by any method, whether it is a matrix method, whether it is a circle method, or time domain approach, or Stockhamp's method. This is the general procedure to follow the convolution solving method. Okay, so go to the problem now, and before that, x1 of n is 1 3 5 7 and x2 of n is 2 4 6 8 2 4 6 8, and I already told, okay, you can observe closely. So in circle method, I will represent the samples x1 of n and x2 of n should be in circle, and entire problem in entire circular convolution method, especially in graphical method, where x1 of n should be a outer circle and your x2 of n should be the inner circle. x1 of n should be the inner circle, and you know that how to calculate the circular convolution of the given sequences. What is the formula? Y of m is equal to summation m is equal to 0 to n minus 1 x1 of n into x2 of m minus n mod n. x2 of m minus n mod n. You can observe here x1 of n is remains same, whereas x2 of m minus n will vary according to the values of m. Either m is equal to 0, m is equal to 1, m is equal to 2, and m is equal to 3. It will vary. Okay, this is the general formula which can be used for the circular convolution. Now I will go with the normal procedure. So I will take as I told already, okay, how to represent x1 of n? x1 of should be outer circle and x2 of n should be inner circle, and I already told x1 of n should be representing in anti-clockwise direction x1 of n should be anti-clockwise direction, and whereas your x2 of minus n should be a clockwise direction. Here x1 of n is anti-clockwise and x2 of n should be minus n should be clockwise direction. Why it is minus n? When you put m minus n in the equation, that is y of m is equal to summation m is equal to 0 to n minus 1 x1 of n into x2 of m minus n mod n. So here length n is equal to 4, so y of m is equal to summation m is equal to 0 to 3 x1 of n and x2 of m minus n mod 4. In the first case, when I will put m is equal to 0, so this will becomes x2 of minus n. How to represent x2 of minus n? Okay, in a circle it will be clockwise direction. It will be clockwise direction, whereas x1 of n should be anti-clockwise direction. Anti-clockwise direction. This you can keep it in mind. Always positive sequence can be represented in anti-clockwise and negative sequence can be represented in clockwise direction. So I will take now my outer circle. This is my outer circle. This is x1 of n. I already told it should be positive, it should be anti-clockwise direction. So how many samples are there? 4 samples. You can divide the 4 samples across the plane. You will get for every 90 degree you will get 1 okay point. So it is x1 of 0, x1 of 1, x1 of 2, here x1 of 3. Similarly, when you put m is equal to 0 in the equation 1, I already told you will get x2 of minus n. So how to represent x2 of minus n? It should be clockwise. It should be clockwise. So here x2 of 0, x2 of 1, x2 of 2 and here x2 of 3. Now what is your x2 of 3? I'll take the sequences here. x1 of n is 1, 3, 5, 7 and x2 of n is 2, 4, 6, 8. 2, 4, 6, 8. So x2 of 0 is 2, it is 4, it is 6, it is 8. Once you draw this, we can multiply the corresponding samples. You can multiply the corresponding samples. You will get y of 0 when m is equal to 0, y of 0 is equal to, I will start with the outer sequence as reference. So 1 into 2 plus 3 into 8 plus 5 into 6 plus 7 into 4. 7 into 4. You simplify, you will get y of 0 as 84. You will get y of 0 as 84. Similarly, now put m is equal to 1. Put m is equal to 1. So what is the formula? Y of m is equal to, means m is equal to 1 means y of 1 is equal to summation m is equal to 0 to 3 x1 of n x2 of 1 minus n mod 4. So you can observe here, you can observe the x2. I already told x1 remains same, x1 of n remains same for all the values of m, whereas x2 of n will vary according to the m value. Your x2 of n will start from 1 sample delay, 1 minus n. It has to start from 0, but because of the delay by 1 sample, it starts the one sample ahead of normal x2 of minus n. So how to represent that? You can closely observe. This is my outer circle. The values will not change, it is constant. For all the values of m 0, 1, 2, 3, it remains same. So we'll have x1 of 0, here x1 of 1. How to represent? Anti-clockwise direction. Here x1 of 2, here x1 of 3. x1 of 3. x1 of 3 is how much? 7. x1 of 0 is 1. x1 of 1 is 3. It is 5. Now how to represent second inner circle? You can observe how to represent x2 of 1 minus n mod 4. So generally your x2 of n, x2 of minus n is clockwise, start from here, but because of 1 minus n, it will start from one sample delay. So your x2 of 0 will start from here. x2 of 0, x2 of 1, x2 of 2, here x2 of 3. So what is x2 of 0? You will get 2. x2 of 1 is 4. x2 of 2 is 6. x2 of 3 is, you will get 8. So simplify, you will get y of 1. What is my y of 1? I will start with the outer circle as reference. 1 into 4. So what is that? x1 of 0 into x2 of 1. So 1 into 4 plus 3 into 2, that is x1 of 1 into x2 of 0. 3 into 2 plus x1 of 2 into x2 of 3. 5 into 8 plus last one x1 of 2 into x2 of 2. That is 7 into 6. You simplify, you will get y of 1 is equal to 92. Similarly, you can observe if it is delayed by one sample, I am start with the x2 of 0 here, one sample ahead from normal x2 of minus n. If it is 2 sample delay, 2 minus n mod 4, then your x2 of 0 will start instead of here, your x2 of 0 will start from here. For then it will be clockwise. Okay. Then for 3 minus n, then your x2 of will start from here. x2 of 0, x2 of 1, x2 of 2, x2 of 3. Then you can multiply the corresponding samples. Then you are going to get y of 2 as 84, y of 3 as 60. Then finally you will get y of n as 84, 92, 84, 60 as the curricular convolution output for the given input samples by using graphical method or concentric circle method. With this, I will conclude my